Our story begins about 4.5 billion years ago. The universe was still young. The Milky Way galaxy, our cosmic home, was already buzzing with activity. Imagine a vast cloud of gas and dust, the remnants of exploded stars swirling in the void. This is the solar nebula, the birthplace of our sun and its planets, including a world that would become known as Mars. Gravity, the architect of the cosmos, worked its magic. The solar nebula began to collapse in on itself, drawn together by its own immense gravity. As it contracted, it spun faster and faster, like a figure skater pulling in their arms. The center of this maelstrom grew hotter and denser. Eventually, the pressure and heat at the core of this collapsing cloud reached a critical point. Nuclear fusion ignited, flooding the surrounding space with light and energy. Our sun, a newborn star, blazed to life. The birth of the sun marked a turning point. The solar system was no longer a chaotic cloud, but a place of structure and order. The remaining gas and dust, remnants of the sun's formation, continued to swirl around our young star, forming a vast disk. This protoplanetary disk would become the cradle for the planets, including Mars. Within the swirling disk of gas and dust surrounding the young sun, a remarkable transformation was taking place. Tiny grains of dust, remnants of the original solar nebula, collided and stuck together. This process, called accretion, is the fundamental process by which planets form. Over millions of years, these dust grains grew into larger clumps, then pebbles, and eventually into mountain-sized boulders called planetesimals. The early solar system was a chaotic shooting gallery. Planetesimals, drawn by gravity, crashed into each other, shattering into fragments, or merging to form larger bodies. In the outer region of the protoplanetary disk, where temperatures were cooler, a young planet began to coalesce. This planet, destined to be called Mars, grew through the relentless bombardment of planetesimals. As it grew larger, its gravitational pull intensified, attracting even more material from the surrounding disk. With the formation of Mars nearly complete, the planet's interior was a cauldron of molten rock and intense pressure. Radioactive elements trapped within the planet's core decayed and released heat, further heating the interior. This internal heat engine fueled volcanic activity on a colossal scale. Volcanoes erupted with unimaginable fury, spewing lava flows that stretched across the Martian surface for hundreds of miles. These eruptions released gases from the planet's interior, including water vapor, carbon dioxide, and nitrogen, which began to form a primordial atmosphere. Volcanic activity played a pivotal role in shaping the Martian landscape. It gave birth to towering volcanoes like Olympus Mons, the largest volcano in the solar system. It also created vast volcanic plains, such as Tharsis Rise, a region dotted with enormous shield volcanoes. The early solar system was a chaotic and violent place, with countless asteroids and comets whizzing through space, remnants of the planet-forming process. Mars, still young and vulnerable, bore the brunt of this cosmic bombardment. Asteroids, some the size of small moons, slammed into Mars with devastating force. These impacts gouged out massive craters, leaving permanent scars on the planet's surface. The energy released by these impacts melted rock and vaporized ice, further altering the Martian landscape. The bombardment of asteroids had a profound impact on Mars's atmosphere. Some scientists believe that early Mars may have had a thicker atmosphere, perhaps even capable of supporting liquid water on its surface. However, the relentless asteroid impacts may have stripped away much of this early atmosphere, scattering its gases into space.